Hello everyone, welcome to the first video of a system design series. So in this series we will be discussing about what is system design, why it's even required, and what are the uh, components for a system design. And we will be also discussing the components of system design in details as well. So with that, let's jump into the very first video of system design. Okay, so let's start with the question, what is system design and why it's even required? So let's start with an example to understand that. Let's say you have a application that can be used for creating, updating, deleting, reading the blogs. And it's a well-written code. It works well on its own. But when that code is deployed to production, there are a set of challenges that it needs to tackle in order to make sure that it works well on a production environment. So what are those challenges that a production environment face? So first challenge that a production application faces is high traffic. So in case there's a high traffic on your system, there you need to make sure that your system essentially works seamlessly even with high traffic. There are no higher latency. Your APIs are not slowing down. It's not like your APIs are getting service unavailable. So this is the one of the challenge that a live system faces. The other challenge is security. Let's say there's a attack by some hacker on your system, so your system should be able to handle that. Your system should be able to not let some malicious request or some uh, uh, malicious malicious request into your system, so that you need to make sure that you are not exposing some personal data easily to someone that is unauthorized. So this is the challenge that yeah, you need to face. And and there are other challenges, like let's say your recent production changes had has introduced some bug. So your systems should be well enough designed in such a way that uh, that bug that is introduced doesn't harm the complete system. It should minimize the impact on users. Ideally, at least minimum number of components should be affected by that code bug, and you need to make sure that you are able to identify there are some alerts or some graphs that you can identify that there has been some issue with the system. And in order to debug those, you need something called logging in your system, so that you can identify what is wrong and you can easily fix that as soon as possible. So let's say there are the challenges as well. Let's say some component is slowing down. You need to able to identify that there's some third party dependency that is slowing down, or not even not responding. So your system should be able to handle that as well. Make sure that you minimize the impact on user, e- no matter what goes wrong. So in order to solve these challenges, we design components. We use some components, some method techniques, so that our system works well under these challenges. So this is the basic idea of a system design. So we will be discussing the a generic system design. So generic system design essentially will be covering all the components that are generally used across all number of systems. And so before that, let's start with the bare essentials of a system design. So first component of a system design can be an API gateway. So API gateway act as a entry point for your system. So API gateway uh, a kind of act as a proxy for your system. So proxy is something that is mimicking the impersonating the actual server. So let's say, so your actual servers will be hidden behind some firewall, and your API gateway will be the entry point for the outside world. Your API gateway is the server that is receiving the request, and that is giving you the response. And that API is public. Other actual components, your actual system is hidden behind its own private network, and that's a security that is done to ensure the security of your system. And API gateway also can facilitate authorized requests. So API gateway can make sure that only authorized requests are forwarded to your system. Other unauthorized requests are responded back with some error that you are not authorized to access this service. Even legitimate users that are authorized to certain service, but they are not do not have access to certain components of system. So those requests even will be reverted back to the client. So this is the API gateway. So uh, API gateway is generally coupled with a load balancer. So load balance, before we can discuss load balancer, we need to briefly discuss the scaling. So in order to make sure that your application can take care of high load, we can do scaling. The scaling means employing more and more, adding more and more resources to your system so that it can take large number of requests or larger number of load. So there are two type of scaling, horizontal and vertical. We will be discussing that after that in some subsequent video. But for the purpose of this video, just keep in mind that there's two types of scaling. One is horizontal, other is vertical. So what load balancer does, as the name suggests, it balances the traffic between multiple instances of your application. Let's say your application is deployed on 3 to 4 servers to take care of the load. So load balancer ideally would make sure that the traffic is distributed equally to each of your instance. So let's say you have 4 instances, so ideally 25% of traffic should be forwarded to one of the instance, and that goes for each component. So each component will get essentially 25% of the traffic. So this is the job of load balancer, to make sure that it happens. And for each application, we have a database. So even database gets uh, scaling issue. In case there is high traffic on your system, your database will have to handle lot of transactions. So there's a quite possibility that your database gets uh, stuck, kind of get slow. So we also need to make sure that your database is able to handle the load, and there are other things that database needs to take care of. Those come those That is essentially a different concept in itself. So we will be discussing that in subsequent video. But database is also a very important component when designing a system. And the other last component can be ELK stack. So ELK stand for Elastic Log Station Kibana. So basically it makes sure that the logs that generated by system, the logs are very important to debug the issue, to make sure everything is running well, or even debug, investigate what went wrong uh, in the past with the certain request or something. So logs are very important for that. And this ELK stack makes sure that your logs are taken care of. Multiple instances of application generate logs. All these logs are combined into one central database, that is Elastic database, and we can go through the request, uh, go through the logs and figure out what went wrong. So this is the ALK stack. There are other components of monitoring as well. We can put alerts on system. Let's say there has been sudden increase in error rate for certain error. We can have an alert to make sure that someone checks that. We can have graphs to monitor number of errors or latency and everything. So these are the things we put in place to make sure that our system works well, and we can preactively take some action before system something uh, uh, troubling goes on. So yeah, so that was the first video of this series. We'll be talking more and more in subsequent videos.